Hi, my name is Charles Kaplan. I'm a professor at the State University of New York at Old Westbury, and this video is the second of 3 or 4 videos. I haven't decided how many I'm going to make yet on the chain rule. So I wrote down a problem, 2 times the 4th root of 4 minus x squared. Let's differentiate this thing. So the first thing we're going to do is we're going to rewrite this, getting rid of the root symbol here. So the 4th root is same as raising it to the power of 1/4. So we have 4 minus x squared to the 1/4. And now let's differentiate this thing, y prime. Well, 1/4 times 2 is 2/4, which is equal to 1/2. Now we're going to just rewrite this. We're not going to do anything to this inside term yet. 4 minus x squared. The exponent, remember, we're going to reduce it by 1. So 1/4 minus 1 is the same as 1/4 minus 4/4, which is negative 3/4. And we're going to now multiply it by the derivative of this inside term. Well, the derivative of 4 minus x squared, let me just go out down here. F of x, let me show you down here, f of x equals 4 minus x squared, then f prime x is equal to negative 2x. So let's go back up here. The derivative of the inside term is negative 2x. So now y prime is equal to, well, negative 2x times 1/2. The 2's go out, and we have negative x times 4 minus x squared. And that's to the negative 3/4 power. The exponent is negative 3/4. Well, negative exponent says, hey guys, throw me down into the denominator. So that's what we're going to do. So y prime is equal to 4 minus x squared to the 3/4 power with negative x up in the numerator. And remember, don't make the mistake of bringing this negative sign in front of the exponent when you're not writing it in the denominator by putting it in the denominator. Once we move this term into the denominator, we lose the negative exponent. So don't make that mistake, because it would clearly be wrong. In fact, if you did put the negative exponent in here, in other words, let me just go down here and say, look, this is wrong. Okay, I just want to emphasize that. And so if I were to write negative x over 4 minus x squared to the negative 3/4, okay, that would be, I better write it on a separate piece of paper. I'm running out of room there. That would be, let me rewrite it up here, negative x over 4 minus x squared to the negative 3/4. Well, that would be the same as writing negative x over 1 over 4 minus x squared to the 3/4. And you can't really tell that's a 3, but to the 3/4. So that's what this thing is doing. It's saying, hey, put this like this. So that would, again, that would be a terribly wrong way to do this. So just remember not to do that. This is wrong. Don't do that. Don't bring that negative exponent. Don't bring that negative exponent down into here, okay? All right, so there's the first chain rule problem. Let's now take a look at another chain rule problem. Oh, and this is a fun problem, this next one. This is another chain rule problem. Okay. So how about this? F of x is equal to 1 over x minus 3 squared. So let's rewrite this. Let's actually square this thing. So f of x is equal to, well, 1 squared is 1, and x minus 3 squared is x minus 3 squared. So let's do that. Now, well, you know what? There's 2 different ways we could do this. We could do this using the quotient rule, or we could do this using the product rule, the chain rule just alone. Well, what should I do? Should I do the hard way first or the easy way first? It's like one of those things. Do I want the good news or the bad news first? I think I'd like to do the hard way first. So let's do the hard way first. So we're going to use the quotient rule. I think that would be a good way to do it, right? Do the hard way first and then show you how easy we could have done it. It's kind of like teasing you. Okay, so let's use the quotient rule. And if you remember, let me get this paper up. Boy, I just don't have the dexterity in my fingers like I used to have. Okay, well, let's move this over here. The quotient rule, if you recall, let's write this down. Quotient rule. Okay, I'm running out of ink in this thing, too. Well, the quotient rule is we start off with a quotient, f of x over g of x, and when we differentiate it, well, we have f prime x, the derivative of the numerator, times the denominator, which is g of x, and then we're going to subtract off the derivative of the denominator, which is g prime x, times the numerator, which is f of x, and we're going to divide this whole thing by g of x squared, by the denominator squared. So again, we take the derivative of the numerator, we multiply by the denominator, we subtract off the derivative of the denominator, and we multiply that by the numerator, and then we divide the whole thing by the denominator squared. Okay? Say that 10 times fast. Okay, so let's bring this guy back. So, let's actually do this. So, f prime x, the derivative of the numerator, well, it's a derivative of 1, which is a constant, so it's 0, times the denominator is still going to be 0, so it's 0 minus, and here we're going to use the chain rule to differentiate the denominator. So it's going to be 2 times, well, x minus 3, we're going to repeat that, and 2 minus 1 is 1, so should I put it up there? Well, I'll put it up there just to show you that I'm not forgetting anything. So we have 2 times x minus 3, and we're going to divide that by the denominator squared, so let's do that. X minus 3 squared. That sounds funny. Squared. Okay, so we have x minus 3 squared in the denominator, so let's start working the problem. This becomes, well, negative 2 times x minus 3 over, well, x minus 3 squared is x minus 3 to the 4th. Remember, x to the a raised to the b, whoops, is equal to x to the a times b. Let me move you over there. Oops, look, I got some ink on my desk here. Okay, covered up. A cover-up. And so we have x minus 3 to the 4th. Well, look at what we have here. We have x minus 3 and x minus 3 to the 4th. So that goes out here, and this is going to become 3. So we've got f prime x is equal to x minus 3 cubed in the denominator and negative 2 in the numerator. So that's sort of the longer, harder way to do this thing. Okay, let's get rid of this. Let me rewrite it here. So we're still doing a chain rule problem. Okay, and here's our function. It's f of x is equal to 1 over x minus 3 squared. So let me get rid of this thing. F of x, let's square the terms again. F of x is equal to 1 over x minus 3 squared. Now, here comes the trick. We're going to rewrite this with a negative exponent and get rid of the quotient. So we have f of x is equal to x minus 3 to the negative 2. And now it just becomes one of those simple, basic, the easiest form of a chain rule that we've got. So f prime x, the first derivative is negative 2 times x minus 3. The exponent is going to be negative 2 minus 1, which is negative 3. I am running out of ink here. And then the derivative of x minus 3, the inside part, is just 1. So f prime x is equal to x minus 3 cubed and negative 2 in the numerator. So this is a negative exponent. So now we're going to kick it back down into the numerator, into the denominator rather. We have negative 2 over x minus 3 cubed. This is clearly a much easier way to do it as long as you recognize that we can rewrite this quotient using a negative exponent. So that's that particular problem. Let's get rid of that. And you know what? We could probably work one extra problem here. You know what? I think I will save the one extra problem. Well, we could work several other problems, and I'll do that in a moment. Let's do that on another video, though. So let's end this video here. I'll get a new marker because I'm running out of ink in this thing. And we'll return with the third video. So we're probably going to have 4 videos on the chain rule overall. So once again, this is Charles Kaplan. I'm a professor at the State University of New York at Old Westbury. This video was on the chain rule. We're probably going to have 1 or 2 more on that. And I have other videos on calculus and algebra and linear algebra and statistics and probability and so forth. So I hope you found this helpful. And take a look at the other ones. Bye-bye.